my area, we are working on safety critical positioning solutions, specifically for the automotive world. So we are typically tier 2 supplier for bigger tier 1s, where we are supplying chips, software for the corresponding ECUs that the tier 1s then selling to the OEMs. Increase of complexity that needs to be managed, and from that perspective it's also corresponding to more complex functions in the vehicles like level 2, level 3 systems for ADAS or also partly autonomous driving or automated driving. There these systems getting much more complex on the one hand, but on the other hand also the safety needs increases there, and the complexity on ensuring the safety is getting also more complex on the system. So we have different standards like the ISO 26262, the ISO 21448, which are the main safety standards. One is for functional safety, the other is for safety of the intended function. And further and further also push to cybersecurity, which was more an implicit part in earlier days, which is going much more explicit with ISO 21434 now that is introduced, and where we also as a tier 2 supplier need to care about and need to manage this. You need to show, let's say, the complete life cycle of the product from your customer requirements or market requirements until testing, verification, validation, that you have done your job at the end. So caring about a correct design, caring the tracing back to the requirements, caring about further the safety analysis, FTAs, FMEAs, to ensure that your development is according to and compliant to the standard. For companies like the tier 1s or also specifically the OEMs, they have partly legal requirements. On the other hand, they're pushing on the other end also for sure the product liability at the end, that they want also to give back to the suppliers, so to the tier 1s and then also to tier 2s. So you need to follow the ISO 26262. And looking on the UNECE R155, for example, which is requiring explicitly something like ISO 21434 on the cybersecurity side, though there are mixed reasons why you have to fulfill it. It's product liability, it's on the other hand legal requirements. From a tier 2 perspective at the end, it's also product liability, but on the other hand also you will just not sell anything if you're not following these standards. Specifically for the IC development, we are for sure using also hardware PLM systems, but specifically for the safety development on our side with complex systems in the automotive world, that doesn't cover our needs overall. Also, if you're using in the IC development hardware PLM systems, we need, on the other hand, for the complexity of the software side, software PLMs that allows us to break it down in subsystem and distributed systems also, for example, and software components, and gives us the ability to model communication, software components, and all the nitty-gritty details in between. We have seen other tools are not as flexible as SystemWeaver, which allows us to adapt the environment to our needs and not vice versa, so that we are not aligning with the tool, but be able to align the tool with our way of working. Enables us really to put all the ingredients in that we need for development in one place, so, and interconnecting them in a semantic way, so we can automatize, for example, also, which is important. And their holistic approach that enables more stringent traceability check, for example, on the one hand, through the whole development from the analysis over the requirements, through the testing and so on, giving their complete outlook. It helps us in the way that it's giving us a continuous state of the data. So it gives us information how traceability state is, for example. It gives us how testing status is in further steps and so on. So it gives us the ability to have at every time through the development process a clear picture of the state of the documentation, the way how the people are working.